Hello everyone. So in this video, we are going to do a quick recap of what we had done in our previous videos. So not the functionality wise, but just the understanding. So in the earlier videos, we saw some image effects. Now, image effects basically are an option given by Unity in a shader, which allows us to uh, manipulate or change the final rendered image. Now, just to go a bit deeper into this topic, I'm going to create a new shader called the image effect shader, and it's going to call it image effect. So we learned that to create an image effect, we need a script on the camera and an image effect shader. All right. What we can achieve with this is what we have seen. If I select one of the cameras, we had created a monochrome effect, we had created a vignette effect, we had created, if you click both of these, a CCTV camera effect, and we had a lot of control over all these things. So to understand what we are exactly doing behind the scenes, I have created a simple C# script, and I just created an image effect shader. Let's take a look at this. So first things first, to enable an image effect, which is post-processing the final rendered image, we need to tap into the final rendered image. How is that done? Unity provides a function called onRenderImage. This function is responsible to manipulate or change the source image, which is the rendered image by Unity, using a custom material which has a custom shader that we are going to provide, and blit or copy it out to a destination render texture. For this, we have an API from the graphics dot blit. If you see, copies the source texture into destination texture with a shader. So that means I can simply say source, which is this source, destination, which is destination, and now we need to give here a material. So to give here a material, we need two things. We need a shader and a material. And this material is something that we are going to pass in right here. Okay. So if we quickly go back to Unity, and once the script is updated, we will check if I have a new camera that is placed somewhere. Let's say here, I'm just going to put it up. All right. So on this camera, I'm just going to switch off the other one. Okay. If I pull on the image effect script, I create a new material called, this material contains the image effect shader, and I drag and drop this image effect here. So we do not need a shader here because we're not doing anything here. I can drag and drop, or I can just provide it to the material. Okay. Now all I need to do is I need to say execute always. So I don't want to just hit the play button again and again to see the changes. So what we have here right now, as we saw, we got the final rendered image, and we did some operations using the graphics.blit using the shader. Now this shader is the default shader given by Unity. So let's go through it. We are done with the script part. Now let's go to the shader part. Shader, if you see, is a file which has a name, some properties, and a subshader. So whenever we say a shader are generally called out as shader programs because these shader programs are effective and used to manipulate certain data or change certain data in the graphics pipeline. So right now, just understand simply that there is a pipeline defined or predefined. Okay. You're taking data through some structures or data structures and manipulating that. Okay. So let's go through these blocks one by one. First of all, we have the properties block in which you can define multiple properties. So there is a syntax of defining properties. Unity provides that in the manual. Okay. We will quickly just see the main texture or the texture property. So this is the variable. The first text that you see is like underscore main text is a variable. This texture is basically what you see in the property block here. So if I select the material, it says texture. Now I can say, if I say rendered, pre-rendered texture, it's going to say pre-rendered texture. And it is of type 2D. It's a 2D texture. Now this value that we are assigning it is a white color. All right. So when we say white with these parentheses, the curly braces, we say it's of white color. So by default, if we don't provide anything, it's going to be of white color. Okay. So now that's done. I'll give you a very simple example of a new parameter called as, let's say I want to have a range, not a range, but some exponential parameter, whatever. Now this is some this can be of type float. Now if I go back to Unity, check the material for the image effect shader, we see it has got a new some exponential parameter called float. All right. So these are the properties that a shader can consist of. Now getting to subshader. Subshaders are another property, blocks of shader. You can write multiple subshaders depending on what platform you are, but let's just focus on the subshader right now. This subshader starts with a couple of tags, like we are saying, don't cull this, don't do a z-write on this, but you do your z-test always. Okay. So these three tags in themselves hold a lot of meaning, and there is a reason why they are here. So we'll go through these one by one in separate videos because this would be a very lengthy topic. For the moment, please understand that as this is an image effect shader, an image effect shader is basically shading a geometric chord on the screen. Okay. And that's why we don't want to do any culling for it. Neither we want to do any writing to the depth buffer. Z-test always is basically because we want to render this thing out always on your screen. All right. Now let's get into the nitty-gritties of the shader. Passes. So you must have already heard about shader passes. Shader passes, you can write multiple passes, and every pass is responsible to have a blending mode. Every pass has a particular structure. Structure is not the structure, but has a particular way of being defined and has to have certain functions. All right, so let's deep dive into this. For us, what Unity provides is a CG program, which starts with CG program as a keyword and ends with NCG. If you miss out on any of these, you won't be writing a CG program inside, and your shader will give you compilation errors. Now, understanding what we were talking about earlier, like a graphics pipeline, a fixed graphics pipeline. So in that, we have a couple of structures, data structures, and we have the option to write out a couple of functions. Okay, so we must have always heard about vertex shader, pixel shader, fragment shader, geometry shader. So these are all programs or functions that we can write and assign. So we start off with the two basic ones. The first one is the vertex. The second one is the fragment. Now we are defining or assigning the vertex shader by the function vert. So if you see, when we are defining the shader or a vertex shader, the third parameter, which is, or the second parameter after vertex, right after vertex, is your function which will define your vertices of the shader. Similarly, for fragment, the parameter or the value next to it will define your fragment function. So if you see, we have a vertex function here and we have a fragment function here. So that is the real basic. The idea is to manipulate the vertices, okay, through the graphics pipeline using the vertex shader, and to manipulate the fragments in the graphic pipeline through the fragment shader. How do we get the information? Perfect. For now, we are going to skip the include CGINC. These are some include files that Unity provides, but we will skip them for now. What we are concerned is with the data structures that the graphics pipeline already has filled up with. So whenever you're writing a shader, you are going to just manipulate or change the data. That is all what you're going to do. You might introduce data into this, but the introduction of data is already done before the data gets onto the graphics pipeline. During runtime, you can manipulate the data. Okay, so let's start off with the basics first. The app data. There are various types of app data structures or data structures, right, that Unity provides. And inside these structures, you can have a lot of other variables. Let's go with the basic ones. What we need to do is we need to get the vertex and the UV. Now, why the vertex and the UV? As I told you earlier, the image effect shader draws a quad on your screen, right? And that is how you are actually getting the final rendered image mapped to this quad. Now just imagine that there is one quad here, all right, on your screen, which goes from UV, which has its UV from 0 to 1. So the UVX goes from left to right and UVY goes from bottom to top. Now, if you want to see that by yourself, to get all this mapping, what we are doing is we're getting the vertices and then we are getting the UV information from the app data, which is pre-filled in. Okay, we don't do that. The GPU or the application basically does that. Now we need to pass this data on to the vertex shader. Why vertex shader? Because once you are providing the application data to the vertex shader, okay, you're saying that I want to move the vertices or the vertex data that I'm getting from the object space to the clip space. Now, again, these spaces are matrices that help define your object or model space and world space, view space, clip space, camera space, screen space. So all these spaces, right, they help you define the position of the vertex where you want to modify the data in. For now, just focus on understanding that there is a quad in a you have drawn a 3D coordinate system and you have drawn a quad inside that. You are going to map it on the screen. Okay, so when I say clip position, it is after the camera clipping is done. All right, so clip space. Now again, what we're doing is we're modifying the vertices to map it to the screen and storing it in a vertex variable of a data structure which is V2F. V2F is commonly known to be vertex to fragment. You can name it to anything you feel like. This data structure is defined by us. Unity provides this data structure, app data. V2F is provided or created, sorry, not provided, is created by us and provided to the fragment function. Okay. Why we cannot pass app data to fragment function? You can do that, but the results that you're going to get are going to be a bit off because you will be working on direct object space matrices. Okay, let's not confuse with that. For being simple and very simple, what we have done till now is app data is a structure provided by Unity that gives us the vertex position in the object space and the UV coordinates. Now, we need to provide this data and provide it to the fragment function so that we can color this out. Now, if you see, we have created our own structure. The signatures are the same. UV is float 2, vertex is float 4. All right. And we are creating an object of this V2F structure, right? And initializing the vertex and UV parameters. For the vertex, we are going from object space to clip space. And for the UVs, we're just copying it over from the app data that we are getting, just as it is. Now, once the vertex function is done, right, and is assigned to the vertex, right, we have to go forth and work in our fragment function. Now, this fragment function, okay, is responsible to colorize all the pixels inside that specific vertices. Now, if you see, for each vertex, right, for each vertex, we have run the vertex shader and provided the vertex clip position and the vertex UV. All right. In the fragment, what we are going to do is, if I remove these two lines that are provided by Unity, we go for iterate over each fragment and we are going to colorize the fragment. So if you see, what Unity did was, Unity directly took the color, okay, from a texture. And now, if you see the code very clearly, it says color.rgb equals 1 minus color.rgb. That means we're inverting the color. But what color are we inverting? We are inverting the color that we have got from the main texture. If you go back, if you see, the main texture is nothing but the final rendered image by Unity that we are using for underlying or overlaying post-processing effects. Now, here you understand very clearly that the property main texture is the one that is automatically getting updated or filled by this function here. So if I was to change the source data, okay, it would result in a different main texture. So you see the mapping? This on render image which is triggered after every frame render is responsible to take this rendered image and then gives us the option or the chance to change or manipulate the color of the pixels using that source and work on the source image. This source image is passed on to this material, which in turn consists of a shader that we had written, which is an image effect shader, and it is passed on as a main texture property automatically. Now, coming to Sampler 2D. Sampler 2D is nothing but just data consisting of that texture. Okay. If you want to go ahead and learn more about these things, we have Sampler 2D and 3D as well for 3D textures. You can go to NVIDIA's website and search for CG functions. CG functions. Another thing is Text 2D. Text 2D is again a CG function that is responsible to extract all the data from your sampler and map it as per the UVs. Now, we have seen this before, but we are going to see this again, that what happens when we just pass on the UV data, right? So if I say, instead of returning color, I can say return 1. So this is something that you will definitely get used to when you're working on shader programs, how you return values. So you see the quad has returned 1. Now instead of this, what I'm going to do is this exp value that we had created as a parameter, I'm going to take it here and I'm going to return exp. But it won't return directly. It gives a pink shader. Why? Because whatever is in the properties block has to be defined inside the shaders pass. If you see, we defined a float. So I'm going to say float exp. And now if you see, we can provide any property from the shader to the fragment function using a property block here. All right. So quickly, let's check one more thing. If I have to return, let's say the vertices, right? So what I'm going to do is I'm going to say return. Now we have this V2F data structure which has a vertex, and this is passed in as an argument to the fragment shader. So if I just say I dot vertex, now see, the thing is, it is already a float 4 type. So you can return this because what the shader wants as an output is a float 4. If you give dot xyz or xy, it's going to give you errors. But if you give x, it works because it maps the x one value x into all the 4 values. So if I just say vertex, so right now if you see, it gives you all white, but there's a bit of a pink and a bit of a blue line at the edge. Why is that? Because now you're in the clip space. All right, you are in the clip space, and that is why it's giving you these values. These are more than 1. All right. If you want to see, you can normalize this. This is again a CG function. Once you have normalized these values, you get unit values. And that is how your vertex or the quad looks in the screen space. Okay. Getting back to another thing is the UVs. The second thing that we're utilizing or heavily depending on is the UV. Now the UV is again a float 2. That means this UV will have an X and a Y value. So if I say UV, it will give me an error because of course it's a float 2, but the return type is float 4 or fixed 4. So we need to have 4 data variables. So not variables, but 4 values plugged in. So if I say .x, we will get the XUV. So if you see, this quad has X going from 0 in the left to 1 in the right. And if you see the Y, we have the V parameter, the UV, which is the Y value going from bottom to top. So it goes ideally like this, 0 to 1. But if you want to quickly visualize this, you can say fixed 4. Now we will get to these variables, or half 4 or float 4. Any of these can work. I.uv.x, I.uv.y, z0 and alpha, g0 and alpha. Okay. I haven't given other. Okay. So RGBA. Now if you see, R is X, which is 0 to 1. Green is Y, which is 0 to 1. And blue and alpha, we are not giving any values. That means red and the green will give you yellow when you go to 1. So that is how the UV space mapping is done. All these things that we went over through, we have used them and we have created effects like monochrome, vignette, CCTV. And there is one more effect that we have created, which is fade in and fade out. So anyways, I would attach the link to that in the videos, and also I would attach the link to all the other videos in this video as well. But I hope some of the basics would have been cleared now, like what the shaders are doing. And the main or the crux of this is we are just manipulating the data. We are just taking the data input from the application and in the graphics pipeline, modifying it and providing an output. So thank you for watching.